Alright, and welcome. The next video I'd like to do is on synthesis. Synthesis really is the exact opposite of decomposition, which in this case is the video I just did previously. And I've intentionally left the decomposition ideas and suggestions up here to show you they're kind of the reverse. Now this is really what we're focusing on here, which is the synthesis reaction. In general, it involves some things, typically two, but sometimes more, joining together into a few smaller things. In this case, just one thing. So I have perhaps a metal joining with a non-metal to form some sort of an ionic compound. Now the typical things here, and some things you want to keep in mind, are like the direct union of elements, and that's kind of what I have here with these first two. Acid anhydrides and water form an oxyacid. Notice that's the exact opposite of this one right here, that oxyacids decompose into acid anhydride and water. Remember that acid anhydride is simply a non-metal oxide, so if I have a non-metal oxide in water, it's going to form an oxyacid. An oxyacid is an acid with an H. Acids have that big H at the beginning, and then it's going to have one of those oxyanions, sulfate, nitrate, phosphate, that sort of thing. And so that's going to apply here. We'll do that in just a moment. And then the third thing I have listed here is the metallic oxide, which is a basic anhydride. Again, it's just a metal. This was a non-metallic oxide or an acid anhydride. Well, this is a basic anhydride. Combines with water, and that's going to form a hydroxide, a metal hydroxide. And again, notice that is the exact opposite of, where is that one? The decomposition of a metallic hydroxide. Here it is. Decomposes into metallic oxides in water. So again, that's the complete opposite of this previous one. So let's go through and do just a few, since these are fairly straightforward. Basically, you see two single elements. The really only thing I could do if I'm going to get a reaction is they're going to join. So what I'm going to do is I'm going to have magnesium joining with sulfur. Magnesiums are +2, sulfurs are -2, so I just have 1 and 1 of each. Then I go back and balance it, and since I have 8 sulfurs, I'm going to have to put an 8 here, and then of course to finish this, we're going to put an 8 there. For this next one, I've got calcium and oxygen, and again, what's going to happen here is I'm going to join those two things together. Calciums are +2, oxygens are -2, so I'm going to have calcium oxide, CaO, and then again we go back and balance it. I have 2 oxygens on the left, so to get 2 on this side I'm going to have to put a 2 here, and then of course we'll have to put a 2 in front of the Ca, and now that one's balanced. Now for my regular academic chemistry students, that's about all the knowledge I'm really going to want you to have. I want you to recognize that when you have these single elements, you're going to bring them together and write the correct formulas based on the charges. For the honors students, again, I'm going to want you to recognize some types. And let's start with this one right here, which you'll see I've checked off. I've checked off a few over here. But in this case, well, it's the reverse of this one. But basically what I have here is the acid anhydride and water are going to form the oxyacid, which is the reverse of this decomposition. So what's going to happen is these are going to come together to form an oxyacid. Well, how would that work? Well, remember the H will always go in front because I'm making an acid. And oxyacids are things like phosphate, sulfate, nitrate, and so forth. So for those, if you recall, I'm going to have a P and then the O for phosphate. If it was S2O5 or S anything over here, I'd have SO something. If I had an N, I'd have NO something. So you're going to have that non-metal in the middle and the oxygen on the right and the H on the left. Now, whether I have phosphate or phosphite, if you recall, those are all -3. So regardless, it's going to be H3. But now my next question is to figure out, well, what's going to be the PO? Is it, PO3, PO4, what have you? Well, for that, again, we come back over here. And if you recognize that oxygens are -2, I've got 5 of them, so I've got a total of -10. That must mean I have a total of +10 charge from my 2 P's. Well, if I have 2 P's here, and they form a total of +10, that means that each of my phosphorus has to be +5. So as I figure this out, my P is going to be +5. My H's are +1, and I've got 3 of them, so they're total of +3. So I've got +3, +5 for my phosphorus. So what does the total O charge needs to be? -8. Well, how many O's would give me that? It's going to be 4. So what I end up with then is my oxyacid is going to be based on the PO4 or phosphate ion. I got that by looking at the oxidation number for the phosphorus, and I applied that over here. I counted my H's. I knew there'd be 3 because whether it's phosphate or phosphite, it's all -3, so I knew I'd have 3 hydrogens. And then just add that up and figure out what do you need for the oxygen. Since they're -2 each, I would need 4 of them. So that's how you figure that one out. And that can be a little bit tricky, but that's all you do. Once you learn how to do those oxidation numbers, this one works rather well. For this last one, what I'm going to do is, if you'll notice, I have the metallic hydroxides decomposed into metallic oxides in water, or the reverse of that is right here, that a metallic oxide and water form a metallic hydroxide. So I'm just going to bring these together and I'm going to make zinc hydroxide. Now it turns out that zinc has a +2 charge, so I'm going to need 2 hydroxides because they're -1. And then to balance this, I have 2 H's and 2 O's. I've already got that over here. I have 1 zinc, and so I'm in good shape. So you'll see, and particularly with these, a little straightforward up here because you're just simply bringing the elements together. With these, just like these guys with a decomposition, you know, these and these are the complete opposite of each other, but once you recognize the types, it's rather easy. If you recognize, hey, I've got a metallic oxide and water, you know what it's going to make. If you've got a acid anhydride or non-metal oxide and water, you know what it's going to make. And it makes things come together a lot easier for you.